This is your 7.2 notes, matrix solution systems of linear equations. And for the end of this section, you'll want to have your calculator out. We're going to be using the matrix menu in the TI-83, TI-84 calculator. Alright, so what this first slide is showing you is just how we set up a matrix, what we call an augmented matrix. If you notice, we take the coefficients and the constants from here. We're taking the 2, the 3, the understood 1, the negative 1, okay? And that's where this is coming from. 2, negative 3. Alright, I always take the sign as well. 1, negative 1, okay? So that's what we're doing. We're leaving the y, we're leaving the x, we're leaving the z. We're not worried about the variables. We're just worried about the coefficients and the constants when we're making what we call this left side is the coefficient matrix, meaning it's the coefficients of the variable terms. And then this right side, on the other side of this vertical line segment here, we have the solutions or the constants. Alright, so this is what an augmented matrix looks like. You have to make sure that you get your x, y's, and your z's together on one side and your constants on the other if you're going to set up an augmented matrix. Alright, and then this thing is called an identity matrix. That's going to be important as we make our way through this last part of chapter 7. But an identity matrix has the property of ones on what we call the diagonal, the main diagonal, from upper left to bottom right, and then zeros everywhere else. Okay, so this is like 1x plus no y plus no z, or just x. No x's plus 1y plus no z's, or just y. No x's, no y's, 1z, or just z. Alright, so that's why the identity matrix is important. It's going to be basically, it's going to show up in our solutions to these things. Alright, a couple of different types, or a couple of different names we have for special conditions that show up. If you have what we call an augmented matrix, again, there's that dash, that vertical line segment that lets us know it's augmented. These are x, y's, and z's. These are our constants. If you have an augmented matrix that has ones or zeros, only ones or zeros on this main diagonal, and then zeros everything below the diagonal, okay? So down here are zeros, but up here not necessarily have to be zeros. If that happens, then you have what's said to be called the row echelon form. Alright, row echelon form, some people call it a lower triangle matrix, meaning that you have zeros below the below the main diagonal. But anyway, the reason why we have a special name for this is if you have a 0, and a 1 here, then it means you know what one of the variables is. You know that z is equal to whatever this number is. Alright, so that's why we have a special name for this. And if we know z, and then notice here we have a 0 here, we have two variables, one of which is z. If I know z is negative 2 and I have z and y are the only things in this equation, then I can plug in this negative 2 here for that z there and solve this for y. And then if I know what z and y are, I can plug those into this equation and solve this one for x. Right? So if you get a matrix into this form, you've solved it. You just have a little work to do, but you've got it solved. You just have to finish up the last couple of steps of back substitution. So that's another important name for a matrix. Alright, matrix operations, these are things that are valid that you can do to any matrix, and you really aren't changing the property or the relationship between the variables when you do these row operations. So basically what this is telling you is what you can do and what is it equivalent to back in the original equation. So this says I can interchange any two rows of a matrix, meaning if I look back at this previous matrix, I can take this second row and this first row and flip-flop them. Put a 1, negative 1, 2, negative 3 here, a 0, 1, 3, negative 5 up here, and I haven't changed anything. I haven't changed any properties about the system. Okay, if you think about it, all I've done is I've just taken this equation and put it on top, and this equation and put it in the middle. That doesn't change anything about the relationship. Okay, and likewise, multiply any row by a non-zero constant. That's just multiplying the left and right side of an equation by a number. Completely valid. Alright, and then 3, add a multiple of one row to another row. Meaning I could take this row here in the middle, multiply it by negative 2, and add it to the top row, and that's like what we did before when we got this a 0 right here. Okay, when we were doing elimination in 7.1. No different than what we were doing in 7.1. It's just we're doing it in a matrix form rather than doing it on a equation or a system. Alright, now, so for an example, we're going to use these matrix row operations to solve this system. Alright, so the first thing I need to do is set up an augmented matrix here. So I'm going to say that this is 2, negative 3, 1, negative 1. There's my augmented line. Alright, and then 1, negative 1, 2, negative 3. Alright, and then 3, 1, negative 1, and 9. So this first step, I'm just taking the system that I'm given, I'm making an equivalent augmented matrix that describes that same system. Now, what do the row operations say I can do? Well, the first thing says I can get I can interchange any two rows. So I can flip-flop this and this. Okay, why would I want to do that? Because this has a 1 in that first position, and remember, if I wanted to do this row echelon form, I need a 1 there. I need a 1 on the main diagonal. Alright, so that's what I'm going to do here. I'm going to try to get a 1 on this main diagonal by doing that row swap. Alright, so row 1 change with row 2. Alright, and I've got 1, negative 1, 2, negative 3, 2, negative 3, 1, negative 1. Alright, and then row 3 is just going to stay what it was, 3, 1, negative 1, 9. Alright, now from there I can multiply any row by a constant and add it to another row. So remember, in that other form I want zeros everywhere else. So I'm going to multiply negative 2 times row 1, and I'm going to add that to row 2. Alright, negative 2 times this 1 right here gives me a negative 2, and when I add it there I'll get a 0 in this position. Alright, now you can do it on your calculator if you need to. So I just take negative 2, negative 2 times whatever is in this position 1, and then add it to whatever is in this position 2. Alright, so I'm going to have a 0 right here. Alright, and then do it again. Negative 2 times what's in this position, negative 1, and then add it to whatever is in this position. Alright, we're multiplying negative 2 times whatever is in row 1, and we're adding it to whatever's in row 2. So negative 3, and I get a negative 1. So right here I got a negative 1. Alright, and again, you can just do it in your head. I mean, negative 2 times 2 is negative 4, and then negative 4 plus 1 is negative 3. Okay, but you can use your calculator if you're not comfortable with your properties of integers. Don't forget to do it to the augmented side, to the constant side. Alright, so negative 2 times negative 3 is positive 6. Positive 6 plus negative 1 is positive 5. Alright, then nothing else changes. 1, negative 1, 2, negative 3, 3, 1, negative 1, 9. Alright, so again, what did we do? Why did we do what we just did? To get that 0 right there. Alright, now what's our next goal? Our next goal is to make this a 0 as well. So we're going to do negative 3 times row 1 and add it to row 3. Okay, so negative 3 times this 1, negative 3 times 1 is negative 3, plus 3 is 0, so I'll have a 0 right here. Negative 3 times negative 1 is positive 3. Positive 3 plus 1 is 4. Negative 2 times negative 3 is negative 6, plus a negative 1 is negative 7. Alright, and don't forget to do the side on the other side of the line segment. Negative 3 times negative 3 is 9, and then 9 plus 9 is 18. Okay, again, nothing else changes. We got a 1, negative 1, 2, negative 3. Alright, now always do it in this order, okay? Meaning we always want that 1 here. I guess I should have put a highlighter on it first. We always want a 1 here and then zeros underneath it. Alright, and then you use row swap if you can to get that first one, that first position there, if you're able to, like we did here. Alright, now after we've done that, what else do we want? If you go back and look, we want a positive 1 here and a 0 underneath that. So that means we need to take this row, right? Remember, we can multiply any row by a constant. So we need to take this row, the second row, and multiply it by a negative. Just negative, the opposite of row 2 basically. So negative row 2, again, nothing else is going to change, so row 1's not going to be affected. 0, positive 1, positive 3, negative 5. Alright, row 3 is not going to be affected because we're not doing anything to row 3. We're just doing it to row 2. Alright, and now we've got a 1 here, we've got a 1 here, we've got 0 here, and 0 here. Now we want a 0 here. Okay, so what do we need to do? We need to do negative 4 times row 2, okay? Negative 4 times this row added to this, plus row 3. Alright, and what's going to happen? Nothing's going to happen to row 1. He's not being used down here, so we're just going to rewrite row 1. Alright, negative 4 times 0 is 0. 0 plus 0 is 0. Negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. Alright, negative 4 times 3 is negative 12. Negative 12 plus negative 7 is negative 19. Alright, and then finally negative 4 times negative 5 is positive 20. Alright, and then positive 20 plus 18 is positive 38. Alright, now again, we didn't do, we added to row 3, so that's what we replaced, was row 3. We don't change row 2, so this is 0, 1, 3, negative 5. Alright, and again, I'm just progressing through here. I got a 1 on the diagonal in 2 of the 3 places. I've got zeros below the 1s all the way down. That's what we always want. Alright, and then what's the last thing I want to do? I want to make this a 1. You want 1s on the diagonal if you can get them on the diagonal. So the last thing I need to do is take row 3 and divide by negative 19. We want a positive 1 there. Okay, so that's not going to affect row 1. It's not going to affect row 2. It's only going to affect the third row. So 0 divided by 19 is 0. 0 divided by negative 19 is 0. Negative 19 divided by negative 19 is 1. And 38 divided by negative 19 is negative 2. Alright, so finally we got what we're after. This is the 1s on the main diagonal, zeros down below it. Alright, again, there's our row echelon form. 1s on the main diagonal, zeros down below it. Alright, 1s on the main diagonal, zeros down below it. So remember, what did we say this means? Because we're leading off with, or sorry, that bottom row is 0x, 0y, 1z equals negative 2. That means zero x plus 0y plus 1z equals negative 2. Alright, well 0x is 0, 0y is 0, 1z is just z, so that's telling me that z is negative 2. Okay, now what's this telling me? This next row, this is telling me 0x plus 1y plus 3z equals negative 5. Alright, well that means that y plus 3 times z, we just said was negative 2, is equal to negative 5. Y plus 3 times negative 2 is negative 6. So add 6 to both sides. Alright, and we get y equals 1. Alright, again, this is what we call the back substitution step. When we take that z and we work our way back up to y and x. Alright, then finally, the top equation says 1x minus 1y plus 2z is equal to negative 3. So x minus y plus 2z equals negative 3. I'm going to substitute in again. We know what z and we know what y are, so I'm going to say x minus y is equal to 1, so x minus 1 plus 2 times z was equal to negative 2, and all that set equal to negative 3. Hold on to this minus 1 for now. 2 times negative 2 is negative 4. Alright, negative 1 minus 4 more is negative 5. Alright, and then add 5 to both sides, and we end up with x is equal to 2. Alright, now do like we did on the last video. Use that store feature on your calculator. Alright, say 2 store as x, 1 store as alpha, 1 is y, and then negative 2 store as alpha, 2 is z. Alright, and now we just go back and write our original equations. Alright, so 2x minus 3 alpha y plus alpha z is equal to negative 1. Alright, and then just rewrite all three of them. You want to make, again, it has to solve all three. So just because it solves one doesn't mean it's necessarily the solution we're after. Alright, so type in each one and you'll see that it works for all of them. Make sure you hit alpha. Alright, so we see that the system is satisfied with the values for x, y, and z that we came up with. Okay, so that is going to be our solution. Alright, Gauss-Jordan elimination. What this basically does is it goes a little further. Instead of just getting a upper triangular matrix, meaning only zeros down at the bottom, we go for zeros everywhere. So we get ones on the diagonals, and then we zero out below, and we zero out above the diagonal. It takes more work, but the nice thing about it is once you have it in this form, there's your solutions. Remember, this is 1x plus 0y plus 0z equals 2, or x equals 2. Alright, this is 0x plus 1y plus 0z equals 1, or y equals 1. 0x plus 0y plus 1z equals negative 2, or just z equals negative 2. Okay, so the nice thing about the Gauss-Jordan or Gauss-Jordan elimination method is once you get that identity matrix on the left, remember that is the identity matrix. If you go back and look, if you get that identity matrix on the left, this is your solution. These values over here are your solutions. Alright, now solution with technology. If you look back, this is the same example we did up here. Alright, I just removed the numbers for the equation name, but this is the same one. Now I'll show you how to do this on your calculator. Alright, on your calculator, above the X inverse button you should see matrix. Now depending on how old your calculator is, you may have just a button that says matrix and you don't have to use the second menu. Okay, on the older TI-83s there's just a button that says matrix, you know, somewhere up here. But anyway, you're going to look for the matrix menu on your calculator. So I'm going to hit second X inverse for the matrix, and these are our matrices. Alright, now I don't have anything in any of them yet, so I'm going to come over here to the editor. Alright, and I'm going to say edit matrix A. Alright, now in here the first number is how many equations we have. Right, so we've got 1, 2, 3 equations, so I'm going to tell it 3. Alright, and then the second is number of variables plus constants. So there's 1, 2, 3 variables and then a constant. So there's 3 variables, 1 constant, so that's 4 columns that we're going to have in this matrix. Okay, so the first one is how many equations. The second one is, when you augment it, how many columns are we going to need for the matrix. Now once you've got it in there, you just type in the coefficients. Don't type in x, don't type in y, just type in the coefficients, and don't forget to not leave off the sign. For the negatives, use this for the negative number. Don't use minus or it'll tell you an error. Alright, and for things like this, 1z, just put a 1. Alright, don't put a 0, there is a z there. Alright, so 1x, negative 1y. Again, don't forget the minus signs. Negative 3. Alright, 3, 1, negative 1, 9. Alright, once I've got it in there, you have to back out of it. So hit second mode to come back to the main menu, okay? And then once you out of it, you actually have to go right back into it. So hit second X inverse, go right back into the matrix menu, but this time we're going to go to math. Alright, we'll come over to math. There's two things I'm going to show you. One is the RREF. Alright, that's the Gauss-Jordan method, or the it's called reduced row echelon form. I'm going to hit that, enter there. It comes back to the home screen and it has a little cursor and it's saying, alright, what do you want me to do this on? You have to go back in your matrix menu one last time and call the matrix. So this time we use 1 for the name. Okay, RREF, hit close your parentheses, hit enter, and there's our solution. Alright, and again we saw this solution just a little bit ago. So this says it reduces down to 1, 0, 0, 0, 1, 0, 0, 0, 1. Again, that's the always the look to the identity matrix. And then 2, 1, negative 2. 2, 1, negative 2. Alright, now if you look back at our solution, we got x equals 2, y equals 1, z equals negative 2. X equals 2, y equals 1, z equals negative 2. So this is the exact same thing. Okay, so you're probably saying, why did you show me all that? Well, because sometimes you have to do it by hand. So doing it by hand, it's a much more complicated process, and it gives you appreciation as well for what your calculator can do with just a touch of a couple buttons. Alright, so let's do one with 4 equations, 4 variables. So this time I'm going to go in here, same thing, second matrix. I'm going to come over to edit. Notice we go edit, then we go to math, and then we go to names. If you just follow along, here we go to edit. This time we've got 4 equations, so we're going to put a 4 here. Okay, 4 variables, 1, 2, 3, 4, and a constant. So that means we're going to take 4 and add 1 and get me 5. Alright, now I'm going to put all this in. Alright, so I've got it all in there. Notice a couple of things. One, this goes X, Y, Z, W. Okay, so it's not in alphabetical order, so keep that in mind whenever you're done. Our top number in the reduced row echelon form will be X instead of W. Okay, so whatever order we put it in here, the column is the order of the answers. Okay, the other thing I want you to notice is that there's missing a Y here and we're missing an X here. Alright, we're missing a Y there, so we got a 0. We're missing an X there, so we got a 0. Make sure you put in zeros if you miss a letter. Alright, if you're missing a variable. Alright, always hit second mode to back out before you go in and do your RREF, and then come back in. Second matrix, go over to math. Alright, come down, you're looking for RREF, enter. Second matrix, come to the name, and again we went in the matrix menu, we went edit to put the 4x5 and put all the numbers in. We went to math, call RREF, and then we went to name to put in the A. So you use all 3 of those menus at the top. Alright, and then there's our solution. Notice we have 1s on the main diagonal, 0s everywhere else. So that means this is the solution. And so we get X equals 1, Y was equal to 11, Z was negative 4, alright, and W was negative 5, I believe. Yeah. Alright, dependent system. Dependent system is like we saw in the last homework set. It means your solutions depend on which variable you want to start with. Okay, x and y will depend on z, or you could make it, you know, z and y depend on x, but usually we let the furthest letter along in the alphabet be the independent and the other two be the dependent. But we're going to look at an example of dependent down here, but if you have a system with less equations than variables, you're either going to have infinitely many solutions, meaning a dependent system, or you're going to have no solutions. Okay, so keep that in mind. If there's less equations than there is variables, it's not going to be a single unique solution. We got to have the exact same number of variables as equations for the hope to be a single solution. But in the case where you have less equations and variables, you're not going to have a single solution. You're either going to have an infinite number, or you're going to not have any at all. Now this one right here has the potential to have a single unique solution, because there's 3 variables, x, y, z, there's 3 equations. Okay, but notice what happens when I put this in on my calculator and do the RREF on it this time. Alright, so I have everything stored into my calculator now. Always remember second mode, go back to the main screen, then come back in. Second matrix, come back in. Math, notice I had changed it to 3 by 4. Math, RREF. Alright, and then call it second matrix A. Alright, now this bottom row, if you look at it, is all zeros. Okay, so this is what our RREF matrix looks like. 0, 0, 0, line, 0. Alright, and then there's other stuff on the other side. 0, 1, negative 3 on the second row on the coefficient side. 1, 0, 8.4. Right, and then the two numbers were 2348, negative 560. Now, a row of zeros like this. This means 0x plus 0y plus 0z equals 0. So this means 0 equals 0. And what did that mean before? It means we have an infinite number of solutions, or a dependent system. Alright, we got a dependent system. Now what are these solutions going to look like? Again, we're going to let z be our floating variable. Alright, so z gets to float. It can be anything. Now notice right here, this equation, what is it saying? It's saying 1y minus 3z equals negative 560. So what I can do to get y by itself is add 3z over. Alright, and what does that mean? It means y equals 3z minus 560. That's the y coordinate. Right? What about the x coordinate? What does this say? This says 1x plus 8.4z equals 2348. So what can I do here? I can subtract 8.4z from both sides. Alright, and that'll go away. And I have x equals this minus this. So that means 2348 minus 8.4z. Now you may be asking yourself, do I have to do it that way? Yes. Yeah, actually, yeah, you have to do it that way. Because what we want, the solution, is anything of this form, where z gets to be anything, right? And then the other two variables, x and y, are defined. This was where X would be. This is where Y would be. X and Y are defined by Z. So Z gets to be anything. Y depends on Z. X depends on Z. Alright, that's what we mean by it's dependent. X and Y, the solution, depends on what this variable is. Alright, and then a applied problem or a word problem where you have to do some setup. Okay. Again, all I need you to do is set it up and you go to your calculator to solve it. So Ace Trucking Company has an order of delivery of 3 products, A, B, and C. These are their products. Alright, this table gives the volume in cubic feet, the weight in pounds, and the value for insurance for each unit. Right, each one of these units. If the company can carry 30,000 cubic feet and 62,000 pounds and can be insured for $276,000, how many of each of these units should they carry? Alright, so we have a system of equations here. Okay, this is our A times B times C. We're letting C, A, B, and C be the variables. Okay. So this is our equation, times B times C. This is our equation. What are these equal to? Well, the total volume, if I add these 3 things together, the total volume can be 30,000 cubic feet. Right? If I add these 3 things together, the total weight can be 62,000 pounds. Alright, if I add these things together, the insurance, I can insure it for $276,000. Alright, and now I just have to set up and solve this. Well, this is the equation, these are the coefficients. So it's like this table is the coefficient matrix, and this is what we augment it with. This is that the constants. Alright, again, this is a 3x4, so we didn't need to change anything. I put in all my numbers. Alright, the 30,000, 62,000. Where did that come from? Sorry, that should be 276,000. Alright, so I've got all my numbers in there. And after I got that, again, second mode to go out, second X inverse to come back in, go to your math feature. RREF is what you want to solve it, if it's solvable. And then come back in, call your matrix. Alright, and then again, we have a dependent system. So if you look at it, this bottom row is 0, so that lets me know it's dependent. And again, we're going to let C can be anything. Right now, the second one, that's B plus 2.5 C equals 2,000. So that means this is B is going to be, this is positive over here. If we go on the other side of the equals, it's going to be minus. So that's 2,000 minus 2.5 times C. That's what B is equal to. Alright, and then A, there's the C. So A, if I add that over, negative 560 plus C is what A is equal to. So negative 560 plus C is what A has to be. Alright, now a couple of things that we can get off the bat. Obviously C has to be positive, okay, because it's number of units of product C. So C has to be positive. C has to be greater than 560 because of this. Alright, C has to be greater than 560. Greater than or equal to 560 because of this part. This right here, 2.5 times something being subtracted from 2000, this b can't be negative, so we can't multiply negative 2.5 times something big enough to where we subtract it from 2000, we get a negative number. Okay, so what makes c times 2.5 equal to 2000? 800, divide it, you can see. So c can't be bigger than 800. Alright, so c has to be less than or equal to 800. And let me just clean this up. We would write that as c has to be between 560 and 800. So this is what our order triple looks like, and this is the bound for the independent variable. C is independent, the other two depend on whatever c is. Okay, now this is something that's a little bit different than a lot of the rest of the problems that you're looking at. These are just random x, y's, and z's. They're not bounded by anything if you have a dependent system. Right, like we did here. Right, we had a dependent system. We just, there's z, there's what y has to look like, there's what x has to look like. Okay, we didn't write anything about what z is bounded by. Alright, but here z is bounded. Right, z, or c in this case, is bounded because it doesn't make any sense to have a negative number of items produced.